Today we're discussing other types of inequalities. We're going to be looking at inequalities that build on the previous section. So in order to solve this one, I'm actually not even going to concern myself with the less than 0 part right now. I'm going to do that at the very end. I'm actually just going to find the boundaries where it equals 0, and then I'll test on either side to see if it's less than or greater than. So in factoring this thing, I'll have a minus 1 and a plus 3, I believe. Let me check that. X squared, yeah. Plus 3x minus 1 is a plus 2x and a minus 3. Good deal. So x equal 1 and x equal negative 3 are the boundaries. That's where it actually equals 0. So I'll put my negative 3 and my 1 on my number line in order, and I'm going to test some points. The first point I'll test is, say, over in here. How about negative 4? Because negative 4 is over there. So I'm going to test that point. So I'll do negative 4 quantity squared. I'll plug it into my original equation, plus 2 times negative 4 minus 3. And I'm going to see if is that greater than or less than 0, because if it's less than 0, then all of these points will be less than 0. I don't care which one you pick. If it's greater than, then all of these points will be greater than. I don't care which one you pick. So I'll have 16 minus 8 minus 3. 16 minus 8 is 8, minus 3 is 5. Is 5 less than 0 or greater than 0? Well, it's greater than 0, so this is actually the greater than section. So that one won't work, so I won't shade that one in. Next point I'll test is one that's in the middle here. How about, say, it's 0? So I'm going to do 0 squared plus 2 times 0 minus 3. And I'm going to see is that greater than or less than 0. So I have 0 minus 3, which is negative 3. Negative 3 is less than 0, so this particular section is a go. He's a winner. So I'll shade him in. Now I'll check this in section here. Let's get a nice color. Let's say a purple. Okay, I need to check a number over here. How about 2? So I will do 2 squared plus 2 times 2 minus 3 and see what that is. So I'll have 4 plus 4 minus 3. And that's 8 minus 3 is 5. Is 5 greater than 0 or less than 0? Well, it is greater than 0. So this section over in here won't work. I need curvy brackets because it is a strictly less than. And there's my graph. Now I'll write it in interval notation, give my answer proper form. Negative 3, comma, 1. And there is my answer. X is in between negative 3 and 1. Next, I'll choose a particularly messy example. In solving these, what you'll need to do is get everything all over on one side. All right. So I must have 2 over x plus 5 minus 1 over x minus 3 is greater than 0. That's what I like. I like for it to revolve around 0. So I need to combine this into one big chunk. So I'll need a common denominator. I will multiply this first one by x minus 3 over x minus 3. The second one will be multiplied by x plus 5 over x plus 5 because they have nothing in common. And I'll put parentheses around this to show that I'm multiplying the entire quantity. Now, lovely thing that I have going on here, 2 times x minus 3 minus 1 times that, so I don't really need to write the 1, just need to write the minus x plus 5 all over the common denominator, which is now x minus 3 times x plus 5. And that's going to be greater than 0 is what I need to test for. So I will manipulate that top, multiply it just a little bit move this up, and I'll have 2x minus 6 minus x minus 5 all over x minus 3 times x plus 5 greater than 0. Even more stunning and this lovely. Now I can combine a few things here. I'll have, let's see, x minus 11 all over x minus 3 times x plus 5 greater than 0. This one is extremely messy, but now I've got it where I want it because I can see that my boundary points are going to be at 11, at x equal 11, 3, and negative 5. I have boundary points, so I'll put them in order on my number line, negative 5, 3, and 11. I'm going to test in between each of these sections. So substituting into my original equation, over here, let's choose a point over here. How about negative 6? I will have 2 over negative 6 plus 5, and I need to see, is that greater than 1 over negative 6 minus 3? And let's see, I have 2 over negative 1. Is that greater than 1 over negative 9? So is negative 2 greater than negative 1/9? Let's see. Nope, negative 1/9 is a little bigger. So this is not true. So this section right in through here does not work. I'll go on to another one. I'll choose number in between negative 5 and 3. Ah, 0's in there. That's my favorite number. So I'm going to test 0. I will have 2 over 0 plus 5. That's 5. All right, 0 plus 5, just so that you can see what I did. Greater than 1 over 0 minus 3. Now is 2/5 greater than negative 1/3? Yeah, it is. So in between here works. Cool. All right. Now, negative 5 and 3, this function fails to exist at either of those points. So even if this were greater than or equal to, I would still put curvy brackets here. But this is a strictly greater than, so they'll all have curvy brackets. But even if it had a squared off bracket, it wouldn't have it at these two particular endpoints because they would make the denominator 0, which would mean the whole function would fail to exist. So let's get a nice purple here and choose a number in between 3 and 11. I happen to like, how about 5? So I've got 2 over, and then 5 plus 5. Is that greater than 1 over 5 minus 3? So is 2 over 10 greater than 1/2? Or is 1/5 greater than 1/2? 1/5 is not greater than 1/2. So this particular section in here won't work. All right. I still have more to do. I still have one more section to choose from. So I'll choose a number over here, say a 12. So I go over to my original equation and I will say 2 over 12 plus 5. Is that greater than 1 over 12 minus 3? So is 2 over 17 greater than 1 over 12 minus 3 is 9. All right. Now, I'm going to have to get these two in a common denominator to kind of figure out which one is bigger because I'm not quite sure which one is bigger, if it's 1/9 or 2/17. So I will need to multiply both of them over on this left-hand side. Top and bottom I'll need to multiply by 9 over 9. And this side I'll need to multiply by 17 over 17 to decide. Now they'll have a common denominator. 18 over, and I don't really know what 9 times 17 is, nor do I care, because it's the same on either side. Because I still have 9 times 17 over here. So is 18 over 9 times 17 greater than 17 over 9 times 17? Sure is. That means that this entire section works. And I need a curvy bracket. Now, I will need to move this up so that I can put this in interval notation and write down my final answer. My final answer looks like -5, 3, union with 11 on to infinity. And there's my final answer for this one. And yeah, it's messy and involves a lot of work, a lot of test points. Just remember, you find the boundary points and then you'll test in between each section to see which one works.